Well, we want to thank our sponsor, Panasonic. Did you know Panasonic supplies some of the top-end ventilation equipment to help keep your clients' homes ventilated and healthy? This 2017 International Building Show Award winners, the Panasonic IntelliBalance 100. This is a customizable, high-performance, high-efficiency energy recovery ventilator, or ERV, ideal for use in any climate zone, including areas like Canada. Has 2 revolutionary DC motors with SmartFlow technology to ensure optimum CFM output. Pick-a-flow speed selectors, 50 to 100 CFM, provide truly customizable airflow, balanced positive or negative pressure. Exclusive built-in ASHRAE 62.2 timing functions helps ensure code compliance and beyond. Connects to existing ductwork or uses a standalone for whole house ventilation solution. And can be used to meet green building certification requirements and help minimize the impact on your HERS index or ASHRAE scores. Designed for multifamily dwellings and new airtight homes, it's built to meet the energy efficiency standards, and it includes an exchange capillary core for recovering heat, energy, and moisture. Comes with MERV 8 filtration, but optional 13 upgrade for replacements, and meets Ontario, Energy Star, and Novo climate requirements. Can't spring for that, then you definitely want to check out the Panasonic Whisper Green Combo Select Cycler. This is a balanced home ventilation solution that is going to allow your furnace to bring in the fresh air, and it will communicate with the bath fan to ventilate that air as it's coming in, either through an intermittent or continuous exhaust, to bring in an affordable, balanced solution to keep the home healthy. On top of that, make sure to check out their range hood pressure sensor, which again is going to activate that fresh air to come in when the range hood is running to ventilate and keep the kitchen healthy, but ensure that balanced exhaust. Welcome to Through the Eyes of the Green Raider, a LEED mid-construction multifamily tour. This course, as with many of our courses, is approved for 1 hour in continuing education units, GBCI, NARI Green, Certified Green Professional, Certified Green Home Professional, American Institute of Building Design AIBD, and may be applicable to your local or state-based design contractor license. This course is also approved for the American Institute of Architects Health, Welfare, and Safety, that's AIA HSW. Today I will be your producer, interviewer, and camera phone operator. My name is Brett Little, and I am the Executive Director here at the Green Home Institute. The Green Home Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. And all throughout these series, we're going to be bringing you behind the scenes through projects that are happening throughout the country, renovations, new construction, single-family, multifamily, mixed-use developments, all getting you in touch with the homeowners, builders, architects, developers, those who do it, why they do it, and the innovative technologies they're using to make homes better. So I hope you'll continue to join us on our ongoing Green Home Tour series.
Good morning. Today we're standing at the Urban 2100 project job site, multifamily complex, and today with us on our lead team we have the ownership group, Jack Hoffman and Dean Larkin. We have the lead for homes consultant, Phil Vetterkind with SBS, and we have Tom Krochek with TGH as our lead for homes rater. Right now I'd like to turn it over to Jack and Dean for a little comment on how the project's been going for them and how LEED reflected on their decision to start the project at its inception.
Hi. This project has been of long gestation because this was an underutilized site that really became an infill site in a fully developed suburb. And we felt that high quality multifamily housing would be a good fit here. And within our ownership team, it became apparent that the financing structure that worked best was to get HUD 221 D4 mortgage insurance to facilitate debt side of the equation. Underwriting rules at HUD provided incentives for green construction. So if we were rated with a recognized green rating service such as LEED, it allowed us to get certain incentives with respect to an interest rate reduction. In addition, we're targeting this project to young professionals, and we feel strongly that the LEED certification of being green will provide us with a significant marketing edge. So we're very excited about it. We've been working with this team and the construction folks and Dave on the green side and Tom and Phil on the rating side, and it's been going smoothly, and we're excited about what we're seeing.
Good. So what we're going to do is take a look at some features as we go through the project today. Some of the requirements that are required for LEED for homes is, well, we've got soil, concern about soil erosion here. We've had these sill socks up. These are made with recycled material, and this has been used throughout the project extensively. We've got a nice stabilized construction entrance here, and also all the sewer grates, we've got fabric on them to keep any runoff going into our storm system here in our town of Wauwatosa. Let's take a look. We have a 4-story all apartment space unit. We've got 97 units in the 2100. This is a sample project. We're going to do 37 of these units on a sample basis at final testing. Let's go look at framing, and let's start our way up to the top.
Hey everybody, thanks for joining us. This is Brett Little, Executive Director at the Green Home Institute, coming to you live from Waukesha, Wisconsin, just outside of Milwaukee, here for a LEED Behind the Drywall tour of a building under construction pursuing LEED for homes, low-rise multifamily.
We're going to take a walk through the first floor and make our way up here. We'll come back down and look at some of the framing details once that's right. They're getting to prepare the outside masonry walls here. You can see they're fully flashing this material. This is a water-based, rubber-backed material that sticks to concrete. This is also part of our durability measures on exterior water and moisture. Let's head up. Okay, so we're on the 4th floor. This unit has already been insulated drywall. Let's step down the way. We're going to go to a mock-up unit we did. There are 25 units on this floor. They're all going through the same air sealing compartmentalization techniques, and we have 2 mock-ups that we have put in our build to guide everybody through as the process goes along. We've had extensive preparation of our mock-up unit to simulate that, and we'll show you some of those details as we proceed here. Our unit is right up the corner here.
One thing that's not obvious now with the drywall is the framing sections were all prefabbed at a factory in Elkhorn, and that allowed for not only precision framing but a lot less waste. And one of the things we score points on in LEED is less waste. And just to tell you how effective that process was, the HUD architect that comes and does the inspections for construction draws says this was the best framing he has ever seen.
And we can show you some examples of how they put those units together on the 1st floor, 2nd floor. Okay, welcome to Unit 423. This is our mock-up unit. We have a little balcony here that's shaded by, again, the roof above. This is a 2-bedroom unit. For LEED, we have to be sure that they are ducted. This will be for the microwave exhaust hood for the little wet paint here. I think they've been here painting recently. To the exterior, that's required. We've also done a lot of compartmentalization sealing. This is an exterior wall. This is a double wall that's insulated for the pipe chases, but that's all clear caulk and that's all been caulked. We've also had clear caulk around the outlet boxes. We get a lot of air infiltration from here. Again, we have to hit our LEED 0.23 CFM per square foot with our blower door, and this helps make the test. We have double glazed, argon filled insulated windows. These have all been sealed with expanding spray foam around the perimeter, and that's the same, and that's the build spec for the whole building. Some other things that we've already prepped for the test for our next second blower door test on this unit. You take a look up at our ducts. This is we're using forced air heating and cooling in the units. They've already caulked the duct boot to the drywall. When we go through the rest of the inspection today, we'll show you some of the taping that was done to ensure that we get great results for our total duct leakage and our duct leakage tests. We haven't performed those tests yet on this unit, but that's coming. Also, all the connections and the areas around the electrical boxes and the ceiling have been sealed. Again, we're trying to get a low air infiltration number, and this is how it's done. Some of that work was even carried out to the inside walls and to the common wall in all these units. There's still some sealing to be done. We're going to try and get gasket plates and on all the switches and all the outlets when we do the second blower door. And that'll help them determine, do we have to go through this extensive caulking, or do we go ahead and use their gaskets and machine to save results? Again, with the compartmentalization that we need to do, we're looking at the best, lowest cost to get our results for LEED, and again, low impact cost for the builders and the owners. We have a couple of ventilation issues in here with bathroom fans. There's two areas. I'll bring some light in here. On this bathroom fan, we have radiation dampers, which is not very typical in what we've seen builds in this area, but they have sealed the drywall around it. They've also sealed, if you could take a look, we found some air leakage through the slots in the housing, and that was fixed. So again, we're trying to get our target 50 CFM intermittent, and we also have a continuous flow rate, which meets LEED and Energy Star, which is part of version 4 for these units. They have passed the initial test. We have to wait for the electrician to hook up the timer so we can actually test the continuous rate. We made some other adaptations in our ceiling for this mock-up. We sealed areas in the floor, and to simulate what we're doing with air leakage from the shower enclosure, we've taped that up to simulate that this is finished. The idea is to give the builder, homeowners, or the owners of the building and the contractor, okay, what do we need to do? How far do we need to go with this? They do want to pass LEED. They want it certified. They want very efficient units for their renters on this property. Okay. This is the second bedroom. And again, we've done extensive clear caulk sealing around all these outlets, especially the exterior ones, and in the common wall. This is the common wall to the next unit. They've actually caulked the drywall to the floor to simulate the gypcrete that's going to be poured in here next week. Once the gypcrete is in, we're going to go ahead and run the second blower door and have a good number. Over here for the test, and this reflects throughout construction, they've gone ahead and we've sealed these back up so that we're not getting any paint, dust, drywall spray into the exhaust fan. This would definitely be a problem at final. You can see the drop here is not air sealed. This is a sprinkler drop. And we cannot disturb that opening that comes through the drywall per our fire code. So this is the second bathroom. So again, everything here, you can see this is clear caulked around the outlet, and again, the penetrations in the electrical box, again, are sealed. This helps us meet our compartmentalization requirements. Maybe that one right there. There we go. Okay. So, we can take a look in the mechanical room. We're using a central return. This is all hard pan to get into here, or hard line. We have our plenum drop. This is the supply drop to the air handler, which will be in here. And we have to do a duct leakage test with this in place. Our big areas of concern are always these tight spaces between the drywall and this plenum drop. Can you come in here and take a look at that? It gets pretty tight. It looks like there might be a couple things they need to get in there and touch up. But again, to keep the envelope tight, the pressure boundary tight, this must be addressed. Okay, we also have our pipes in the wall. These are typical, where we may have leakage. This has all been sealed up. And our laundry. We have a LEED requirement we'd like to show. Our laundry is it's in the other room. You have it? Pardon? Oh, okay. Okay, so what we've discovered is, for our test, is they've actually air sealed. Again, we talked about getting a tight air seal. This is a fireproof type caulk that's up in here. The tape is on here for my lower door test. But we've got this caulk and the housing around here. The way the housing fits into the framing and the drywall, we were getting a good air leak here. So again, we're trying to compartmentalize this unit, seal it up tight, and this is one area of concern. We also have this area, which is a LEED requirement. We have a washer and dryer above a living space. So the owners have decided to invest in this approach, which is an automatic electric shutoff versus a floor pan, a drain, and maintenance with those issues when you have another drain under a pan. So this meets our LEED requirement for, again, any kind of washing machine over living spaces. Okay, and I'll button that back up. So, we have, this unit is 1,179 square feet, 2 bedrooms. Of course, everything was closed and sealed up when we did our blower door test. But here's the result of all this. This is not finished. We are looking at currently at 3.74 air changes per hour. That would be under the old league standard of 2009. Under the new V4, we're at 0.2. We're not finished. Okay. So we have to do another test with simulating the gaskets on, jitcrete will be in, door hardware will be in. All that stuff will make a big difference, and it'll help us get a little lower number. But we already are at the LEED V4 requirement, below 0.23 CFM 50 per square foot of apartment area.
So this building is going LEED for home low rise 2008.
Correct.
Right. So the first number you were talking about, the 3.7 ACH, was your sort of total air changes per hour for energy, right?
Correct.
And then you're just referencing the CFM per square foot of building envelope, right?
Right.
For V4.
Right.
And just showing that, hey, if this was a V4 project, they are on track.
And if we do really good on this one, there could be another V4 right behind us with the doors, depending on how this all times out.
Yeah.
So we're very impressed with what everybody has done so far. We've also had the contractors in here. We logged the time for contractor training, which is another innovation credit we could get. And they're more than willing to spend the time with us and go through this for the respective trades as we deal with this project. So, good, Phil, or any questions, Phil? Or
You're doing great.
okay, I've done this before.
What kind of HVAC system?
This is a conventional forced air system. We're using a 96% variable speed furnace, and we have all our condensing cooling units on the roof. Those are all put up prior. We were on the roof when we had access to the roof to see how the roof is sealed and how things are insulated on the roof. That's at the beginning of the construction. We didn't really get on the site till the roof was on, insulation was being put on. Because there's no stairs, you got to use ladders to access the site. So this is unit 423, and we can have some follow-up on this when we're done testing it here in another week. Let's take a walk down the hall. And here we are, 408. And we've got somebody working here, but we'll talk our best as we can. This is a one-bedroom studio apartment. Again, we're looking at, we do have arc ducted range exhaust for the microwave in the cooking area. We do have our, again, 4-stair ducts coming down from in between the floors for heating and cooling. As you can see, they've been taping those up before they paint. We do want to claim some credit for, again, keeping the system from contaminants during construction. Okay, this has a little island in here. Again, they need to get in here and do their caulking before we come and again do the blower door test to see how the infiltration rate is. They haven't quite got that far.
And this is an interior wall right here. Right?
This is an interior wall to the corridor, and this is a common wall to the unit next door. We also have in this area, we have a bathroom. Again, compartmentalization, that stuff must absolutely be sealed. We haven't gotten to that for our test yet. And again, this is another area. They do have some daylight coming in here, which is nice because they've got this 3/4 wall. Again, we have our HVAC, and they have sealed properly all the way around the ductworks. We are going to do a total duct leakage test on that, on this unit, also on the other demo unit, because we want to see how it rates to V4. Even though V4 is not required for this project, we are getting the builders, the HVAC contractors, and the drywallers up to speed on what we need to see. And they're willing to do it. There's not that much cost to do this at this stage of the game. And here we have just a data panel for all their low voltage, their wiring and stuff. Okay, so this is 408. Demo will be coming up next week. So, should we proceed down to the 3rd floor? We have some insulation we can look at. And it's half drywall, but we can take a look at what's going on there, and we can proceed down to a floor where we have just mechanicals. You may want to take a quick look here. This is where any of the ductwork and wiring and our sprinkler runs are hidden. This will have a drywall ceiling on it, and right above us is the roof, which is all expanded polystyrene, several inches thick to meet an R44 requirement.
Also, all the insulation is exterior?
Pardon?
On the roof, the insulation
Yes.
is all exterior?
Exterior. So our thermal boundary is the roof deck, and this is just air within the corridor. Okay. So we're on the 3rd floor. Half of these units, there's 25 on this floor, are drywall. So we're going to walk down to the insulation area. They're in the process of taping and mudding right now. All these systems will be hidden in the soffit here. These are all the gas pipe runs. Fire protection. And we'll go down where it's a little quieter. So what we have is this is a common wall to the corridor. We call this an adiabatic wall in energy modeling. This is an R19 bat that's in this wall, and Again, we're a 2x6 wall. Inside this unit, we're going to look at some of the things we talked about earlier. Okay, we have R11 bat in this common wall to the common wall. So on both sides of the wall, we've got R11. They use that for sound attenuation, but it also does help in our energy loads a little bit. This is an exterior wall here where the poly is. We have R19 bat in these cavities. Also, we've got extensive caulking of all these joints. Again, as Dean pointed out earlier, these are all panelized construction assemblies that went into this building. So we've got caulk between the framing members, that's generally where the gaps are. And also they're finishing some caulking here on the horizontal seams. They've already caulked the floor, but they've got to get at this area here, which is between these floor plates for this window assembly. This is where we can get air filtration into the unit. You can leak in, and that's what we don't want. We already got our hard pipe in for a range exhaust, and you can see for the HVAC, for the supplies, they've taped these up to keep the system totally clean before final. We have expanding foam here around our rough openings for our balcony doors. Okay, and again, once they get the gypcrete in here, that'll help seal everything up. All right.
Is there any ceiling, you know, behind some of these walls too, just around the edges, or no?
As far as
caulking or anything?
As far as caulking, no, they've done it on this side.
Just there,
they
okay.
do have an air barrier up. It's a drainage plane.
Okay.
They have a commercial wrap, and we can actually get a picture of the commercial wrap here. You don't want to fall through the door, but this is a special drainage wrap that has grooves in it. And again, this is a great point for our exterior water moisture requirements. There's going to be a siding material put up behind this that has an air gap in it. They'll cover this, and then we'll get our proper drainage. If you take a look here, you can actually see how they flash this window assembly. We do have our house wrap, we do have our window wrap, and again, done in shingle fashion to prevent water from coming in any window assemblies. The seams and also the wrap, exterior building wrap is also been taped. So this is a nice little balcony here for this unit. Okay, so one of the things that we look for in our inspection is this area. Again, as we saw in Unit 423, we had tight space. This is nice. We've got plenty of room around here. We can get the drywall really tight because this is a high duct leakage area, and also here high infiltration area if we don't do this the right way. Okay, we have a bathroom over here. Okay, you can see that they have, enclosed the bathroom fan. They don't want that housing getting full of paint and everything. And then also for compartmentalization here, we've got a nice example here of air sealing. All the penetrations through these top plates, though we're all within the envelope, are all fire caulked and sealed, including the AC line set, any PVC venting, or again, any kind of drains that might come from above. So they've done a really good job with that. They weren't afraid to use caulk. You can also take a look here. You'll see it with the electrical wires and also the supply pipes for the shower.
Mm-hmm.
Okay. We have an R11 bat in here. This is used for sound between the floors, and that's what they're using here. And they're using an eco-friendly, or they're using a formaldehyde-free or low formaldehyde bat product for this entire build. Again, all the exterior walls are fiberglass bat, common walls to the corridor and to the units. So this is typical. They just have to get some of this insulation maybe layered a little better. It looks a little droopy here, but again, this is for sound. They should, really kind of watch the bats, that we don't bypass anything here.
From a HERS grading, what levels are you seeing these come in at?
Well, from a HERS rating, we can only do projected ratings.
What I meant to say is HERS, like a grading the insulation.
Oh, grade insulation?
Yeah.
Common walls would be a 2, exterior walls would be a 1, and this would be probably a grade 2 to 3.
1 being the best.
One being the best, correct.
Yeah.
These are conditioned to the corridor, conditioned to the unit. We call those adiabatic walls, and sometimes that does not make a difference. If there's nothing here at grade 3, that would make it a big difference in our heat loads to the building. So here we are. This was unit 311. Okay. So let's take a walk down to the second floor and let's take a look at some framing. Let's take a look at this one, 301. We had some concerns on some of these units on the west side of the building because of the possible air infiltration in the envelope. And it was this area right here. We had some of these triangular dead chases, but they had gotten enough wood on here and sealed it. Again, we didn't want any kind of thermal bypass through a detail like this. Though it's all in the conditioned building, the fact is we can get air leakage through the insulation. We can get it through the cavities above us. Again, here they've done a nice job, very good job of, again, fire caulking and air stopping these common penetrations that go up through our top plates. Okay, and then again, these areas that have the poly on them are outside walls with R19.
Mm-hmm. What kind of windows are these?
These are Pella. These are commercial low E glass, argon filled, and there is no typical NFRC rating, but we do have a sticker. We do have the specs from the manufacturer. They come in at 0.27, 0.25 solar heat gain. Again, a nice one-bedroom unit. If we go over here, we can look at our plumbing again, the laundry. You can see they've got the automatic shutoff valve already put in, ready to go. And our laundry vent housing, they've got that in, that's all caulked, and we're pretty well ready to go. This operates with a sensor that's on the floor that shuts those valves off.
Oh, so if there's a water leak, it'll just shut it off.
So in final inspection, we'll be sure that that's all hooked up, and we're going to take a look at all those. Okay. So here's another area of the chaseway that could be a problem. We want to be sure that this is all sealed here, and I have to come back and check to be sure that we don't have too many penetrations like this. This would probably have to be remedied before we go ahead and drywall this unit. So I'll be doing a complete insulation inspection on this floor after this video. Okay. Down to the second floor. We're using an unfaced fiberglass bath, R11. Let's take a walk down this floor. We're at unit 208. This is a mirror of the unit 408 we looked at that was drywall. It's a good unit to show our audience today exactly what's going on with this duct system. As you can see, they've used a combination of materials, duct mastic, and they've used foil tape. Again, it's a commercially rated fire code tape they have to use. You're looking at the fire damper that's in the housing and the duct boot that drops down. When we initially did the test, we were having some leakage issues, so they went ahead and sealed it from the outside and inside, and some stuff in the shop prior to the job site. So again, when we're doing duct leakage testing for leakage to the outdoors or total leakage, this detail is extremely critical. The way they've designed this system is they've got a central round plenum here with takeoffs. Those are gasketed, but those are also sealed. And the duct leakage test will tell them how well they did. We've done one of these at rough, and they were way under the target for duct leakage for that particular unit. And this is a good time to test it while we can still get at everything. We found leaks in little simple details, but again, it did pass because they did a good job on the onset. This is where we have the biggest problem with Energy Star and with that requirement under V4 is the duct leakage on forced air systems. They've already got this one piped in for the range exhaust. They went the extra mile and sealed all the pores, all the connections, and that goes all the way out. We have to hit 100 CFM flow. We should be able to hit it with the design of this duct system. Again, checking here. Again, all these penetrations going up, including the dryer exhaust, have been sealed in the top plate so that we're not going to have this air leakage into this envelope at the ceiling level. And here they've got to do a few they've missed. So there hasn't been a formal framing inspection on this floor yet. That is going to be next. You can see they've already started talking. Some of the framing members. And Dean talked about how this is all prepackaged. This unit came in on a pallet. All the inside walls are numbered. You take a look at these, and we should have numbers. Okay, we have truss numbers, of course. But right here, this is package 786. So all these interior wall sections came in on a pallet, and it was put up. We didn't have all this cut framing and lumber waste from here, as Dean had mentioned earlier. So the whole unit came in, all these interior walls, anything on the interior, because all that was here were trusses when this was put up. So this is all built and all numbered. Okay, and then
That was all made in Wisconsin?
It was all made in Wisconsin within a 50-mile radius of this building. We're insulating the masonry wall to the unit. They're also fire blocking this framing. That hasn't been done yet. They're still working on the roof on this floor. Okay. This unit's going to be a little different to test for a duct system. Because of the glass area for the ventilation requirement, there's this fresh air makeup duct. It is insulated to reduce any potential condensation, interstitial condensation between the floors, right? Well, it is timed so that when the air handler comes on, we draw air, but it's also timed to our bathroom fan. This is a one bathroom unit. A bathroom fan has to have a certain CFM for LEED, for Energy Star. And it's going to be a little interesting to try and test a system that is drawing air in, trying to do a blower door. How does this work? Or when we're doing our ventilation testing for the bathroom fan, how does that work? So we have to have an HVAC tech here on site who put this in to guide us through the testing. We don't understand the system. We bring in our tech support, these people that worked on it to help us. And that way it all works, and we don't do something that we're not supposed to do. Again, we got a nice plenum drop here. We got plenty of way around it. We can air seal the drywall. And here's our central return.
What were some of the benefits of the way you did the framing more prefabricated than doing it on site?
Well, first there's efficiency. In terms of the crews putting things together, they could move more quickly. Second thing, much less waste. Everything was the way it was designed and the way it was assembled, much less waste. Third thing was weather control. So, construction site, it's amazing. You get every vagary of weather. You think you're sheltered, but everything gets wet, the rise gets wet, dries. This stuff was put together in a factory, so it was assembled dry. It comes to the site, ready to go. So it didn't get subject to that, the vagaries of weather again. So lots of benefits doing it that way.
Any cost trade-off, savings?
You know, we really didn't study that so much. It was the way the project was bid and the way it was decided to go. So it's really the current state of the art. And since we were going green, we understood that the benefits would weigh in heavily to achieve points on LEED.
Sure.
So that's the road we traveled.
Sure. Thanks.
So let's proceed downstairs. One of the few common areas in the project on this floor. And they've sprayed all this. These are all metal columns. They sprayed this for fire protection. Again, we're using the same kind of windows and door assemblies throughout this project, same kind of energy ratings, and they're installing them the same way. This is still under rough mechanical. They haven't finished everything. And we have a very interesting deck out here that we want to take a look at. Gotta watch out above.
Yeah.
So the owners have applied for, right, if we can get them back out here. Let me talk about this for a minute. So you mentioned you had gotten some grant from our local sewage district on this particular feature of the building, Dean?
Right. We applied to the MMSD, Metro Milwaukee Sewage District. They do, you know, as you're probably aware, they're very concerned with stormwater runoff because a lot of stormwater runoff overburdens the system during periods of heavy weather. So they encourage property owners and developers to try to come up with ways to retard the flow of stormwater in the system, and they financially incentivize you to do so. So this project has a couple features, and we applied for a grant based on having incorporated those features in design, and we were lucky enough to receive the grant. So one of the features is a green roof. You're standing on the green roof right now. So what will happen is this is the base, and we'll have a system of pedestals and planters with planting sedum, which is perennial. It's really a cool little plant because it flowers in the summer, but then in fall takes on like fall colors, almost like a tree. So in addition to the people on this level having that as a benefit, you know, when they're out on their patios to have a visual, the people up above will also be able to look down on it. So we'll have a wall here to kind of make this space a little more intimate. We'll have a grilling station for the public space to come out here and enjoy the green roof, but it's going to provide a benefit in terms of retarding stormwater. So kind of a win-win, and again, we think that the LEED rating and the green features, you know, the younger professionals value things like that. They understand, you know, they want to be good citizens of the earth, if you will. So we think that's going to be helpful in terms of leasing the project, knowing that these features exist. We're going to have species of trees that are thirstier, if you will. We're going to have a green bioswale to retain some stormwater, but probably the signature feature is going to be our green roof.
One of the things I want to show you about some of these exterior walls. These are these panels that have, they're sealing the seams between, but the drainage plane we looked at earlier is actually a spacer in here that has holes. So all that water that may propagate through here, there is a drainage path out. It's very well flashed to come out. Again, this is going to be a green roof, so any water that drains through here will feed the green roof. We've also extensively flashed the case patio doors, and there's still some work here that's being done. But again, they've also blocked properly. Again, exterior water moisture. We're near Lake Michigan, it's important. If you take a look up in some of these other areas, they've also caulked these pipe penetrations coming through the wall. That's part of the standard. They've already started putting on the vents for the bathrooms and also the rain filter. So they're working on this. The unique part about this area here too, they're using a leaf screen behind this wall.
Sorry, a rain screen behind the wall?
Well, there's kind of a drainage plane that's a 1-inch opening. The motor is not slammed up against the water barrier. There is an airspace, and we have water draining out the wall several points around where all the masonry is. Here's an example too, where they have to put the material in, but again, it's another drainage point for these walls that absorb a lot of moisture. Very good. What's going on?
Yeah.
So we're in the, Dean, how far are we through? We about halfway through construction?
About half, yeah. Just
Okay.
maybe a hair more, but about halfway is
Okay.
a good number.
And then we'll be back in, I think, mid-December through mid-January doing the final performance testing on 37 sample units. The demo was really important because it shows what we need to achieve, right, in our testing. And it makes it fair for the owners, because we're not saying we're testing this one and that one. The whole building is built this way, and that sample is only known to a few people, and that only comes out the week they say we're ready on the 4th floor. I say we need this unit, this unit, this unit ready. It works really well in that system. So that's what we're all about. We started this, what, how long ago, Dean?
Oh, we started construction in basically December of 16.
Right, we started talking about LEED back in May of 2016.
7, 8 months.
Yeah, so it all works. And Dave, do you want to talk a little bit about the SETI or that part of
Yeah,
Energy
so
Star?
what we did at the beginning with the owner, the architect, and the engineering team is we performed a SETI, which is a statement of energy design intent. That's part of the HUD 221D4 requirement, is to baseline the building as to how the building is going to perform once it's occupied. In doing that, we came up with an EUI, an energy use index, and everything that Tom's been testing here is our HERS rater, and everything that Dean and Jack and the ownership and the construction team itself has done is going to help us achieve that EUI once the building is occupied. So ultimately, everything we're doing here right now is going to end up with a much better, energy efficient, better performing building in the long run.
So does the building have a specific goal as far as LEED level, HERS rating, and EUI, if you could share those?
Right now for LEED, we're just going for certification. I think we're going to completely blow that out of the water. I think we'll be really good. I don't want to make any commitments right now, but we should end up really well at the points we're attaining during construction. On the EUI side, our goal is to get Energy Star certified. And although when the SETI was done almost a little over a year ago, that's kind of a sliding scale.
Right.
Because as EUIs change and buildings of the same magnitude and the same demographic become more energy efficient, then Energy Star score continues to increase over time. So our goal is to meet the EUI that we anticipated in design on paper on the SETI, with a stretch goal to actually get the Energy Star certification for the project this year.
All right, well, thanks, everybody.
Thank you, Brad, for coming out.
Yeah.
And before we close out, right before we, right after we filmed this, we reached back out to our rater, Tom, and got some more details, as he promised, of the mid-construction review. And he said during the mid-construction blower door test, the second test, after the gypcrete floor installed and there were no further caulking and sealing, they resulted in a 570 CFM at 50 pascals, as you would normally do blower door testing. And according to Tom, this is equivalent to 3.2 air changes per hour at 50 pascals. And if you calculate that to the new LEED metrics and actually the new metrics that Passive House and many other organizations are using, you're going to end up with 0.15 CFM per feet squared of building enclosure. And the neat thing about that is our target compartmentalization metric for the new LEED rating system. So very important that these contractors were going through that with Tom, training them how to do this. It's going to be very important moving forward as you talk to your contractors and subs, understand what their blower door results are between units for the health and occupant of comfort, or of health and comfort of occupants. In this particular course, we're going to be going through mid-construction, pre-drywall inspection, so mid-construction and a pre-drywall inspection, and that's through the eyes pretty much of the LEED Green Rater, Energy Star Rater of a new multifamily market rate construction. As far as LEED credits specifically, we'll be looking at LEED Building Design and Construction V4, environmental quality prerequisite, compartmentalization, so tightness of units. We're going to be looking at the installation, how it's done, what the benefits are both on the exterior and with interior units, and how that's tracked within the minimum energy performance. We'll be looking at occupant health strategies and contaminant control through the LEED rating system, and try to help you understand the benefits of a third-party green rater on any project that you do. So join us. All right, well, that is the end. Thank you again to all of you for watching, all of our members, our sponsors, our board of directors. Thanks to our volunteers. Thanks to GeoComfort, Build Equinox with the smart ventilation system, Sun Intuitive self-tinting glass, Niagara Conservation, Panasonic Ventilation, and Certainteed Air Renew formaldehyde eating drywall. Couldn't do it without them. We couldn't do it without you. To pick up your continuing ed for this course, make sure to complete the 10-question quiz and then get an 80% passing rate. Please join us next time. Thank you.